Welcome to the second video in the FISAB training series on European fire safety regulations for sandwich panel products. In this video, we will dive into what sandwich panels products are and examine their performance at normal temperatures. What are sandwich panels? Well, they are a building product made up of two metal faces with a core of thermally insulating material in between. This core is tightly bonded to both faces with adhesives, enabling the entire structure to work together under load. Sandwich panels are known for their excellent energy efficiency, lightweight design, and ease of installation, along with their durability and low maintenance requirements. Sandwich panels can be categorized based on shape and core material type. Typically, the core material comes in a few different types such as mineral wool, PUR or PIR, and the panel surface layer can be flat, lightly profiled, or profiled for extra bending capacity if needed. The steel sheets are typically used as the metal facing material as it melts around 600 degrees centigrade. The sheet is galvanized by being coated with a zinc layer between 100 to 275 gram per meter square by using the hot dipping method, which is produced on highly automated continuous lines called coil coating. The surface finish is usually a thin plastic coating whose compostable content can be ignored, but a check needs to be made that the coatings have the required low level of flame spread and other reaction to fire test requirements. The calculation of the reduction in the strength properties of steel at elevated temperatures shall be in accordance with the EN 199312. The figure here shows a detailed view of all the layers composing a galvanized steel sheet attached to the core material of a profiled sandwich panel by adhesives. The core material plays a crucial role in sandwich panel performance. One popular option is mineral wool. Mineral wool is a great choice because it is fire resistant, unlike other materials that might contribute to a fire or release harmful fumes. Mineral wool stays strong and does not produce flaming droplets, even in a fully developed fire. This means that buildings with mineral wool insulation are more likely to withstand a fire. But that's not all. Mineral wool also has excellent acoustic properties, so it helps to reduce noise transmission. Mineral wool is also water resistant, making it ideal for use in a variety of climates. However, while mineral wool is a fantastic option, it is important to consider other factors when choosing a core material, such as thermal insulation requirements, self-weight, and cost. By carefully weighing these factors, you can select the best core material for your specific project. PUR and PIR have a unique advantage when it comes to fire resistance. Unlike some other materials, they form a char which acts as a barrier to prevent the fire from spreading within the panel. This means that even if one part of the panel catches fire, the flames are less likely to spread to other areas, providing valuable time for firefighters to respond. However, PUR and PIR cores on their own typically have a fire resistance of around 15 to 20 minutes. This is because the insulation can fail under prolonged exposure to fire. On the other hand, PIR compared to PUR has a higher degree of aromaticity. This makes them more thermally stable and produces less smoke, enhancing their fire resistance. While PUR and PIR materials might not be the best choice for applications requiring extremely high fire resistance, they offer excellent thermal insulation. They are also lightweight and have low water absorption. This makes them ideal for a wide range of construction projects. The adhesive that binds the core material to the metal facings plays a crucial role in the structural performance of sandwich panels. Most commercial sandwich panels use one or two component polyurethanes. These adhesives are strong and can withstand high temperatures, but they start to soften around 150 degrees Celsius. This is important to remember when designing sandwich panels, especially for applications where the panels might be exposed to high temperatures. In auto-adhesively bonded panels, the foamed core material itself forms the adhesive layer during the foaming process. This can simplify the production process and reduce costs. However, it is important to note that the fire-exposed metal facing of a panel using slabs of core material can delaminate early in a fire. This is something to consider in fire design to ensure the panel's structural integrity. Additionally, the amount of adhesive used can also affect the panel's fire performance. Using less adhesive can reduce the amount of heat released during combustion, which is generally a minor factor in fire design. This example shows the fire exposure to a PUR core material and the charring effect it creates. While the fire load of a PUR panel is significantly higher compared to a stone wall panel, its thermal insulation performance is superior to that of stone wall. Here are the shear and bending force diagrams for a sandwich panel subjected to a distributed load, for example, wind or snow load. A general assumption is that all of the shear force is resisted by a uniform shear stress in the core, and that the bending moment is resisted by axial stresses in the faces. The adhesive bond between the faces and the core will carry a shear stress equal to the shear stress in the core. For the structural design of a sandwich panel, it is necessary to consider multiple potential failure modes. Figure D shows, in an exaggerated form, the slippage caused by using an adhesive with low shear strength. Figure E illustrates the consequences of using a core material with insufficient shear strength or stiffness. The prevention of this undesirable behavior requires a core with a sufficiently high shear modules as well as adequate shear strength. In Figure F, as the upper face of the panel is in compression, another important function of the core material and its adhesive bond is to restrain the upper face so that it does not suffer local buckling in compression. Wrinkling failure is dependent mainly on the stiffness properties of the core. And this is another reason why the mechanical properties of the core play a critical role in the structural design. The final mode of failure is tensile yielding of the lower face. This is generally the least likely of the alternative modes shown. Generally, the situation becomes more complex when the sandwich panel spans over multiple internal supports or when one or both faces are fully profiled. This makes the structural design of sandwich panels quite challenging. That's it for this training video. In the next video, we will talk about the behavior of sandwich wall and roof panels when exposed to fire. Thank you for watching and see you in the next video.